All right, so if you watched the two videos before this, what we were looking at is the ambiguous case side-side angle. And we constructed these in class, but when x was 5, z was 8, angle x was 26 degrees, we saw that we had two possible triangles. When x was 9, z was 8, x was 26 degrees, we had one possible triangle here. And then when x was 3, z was 8, and x was 26 degrees, it didn't create a triangle at all. Well, we already went through in the previous video how we could find the possible side lengths for y, which is just another way of proving how many possible triangles there are. We're going to do the same thing now, but we're going to use the law of sines and look at the possible angle measurements. Another way to prove what we already know, 2, 1, and 0 possible triangles. So we're going to start by looking at the two possible triangle case. And so we know that we have a 26-degree angle, and across from the 26-degree angle is going to be the 5 centimeters x. And so we're going to try to find possible angle measures for angle z, we'll say. So the sine of angle z is across from the known side, which is 8. From here, using the law of sines, we will cross multiply, and we'll have 8 times the sine of 26 divided by 5 will end up equaling the sine of z. From here, to find an angle, we're going to do the sine inverse. So we'll have 8 times the sine of 26. Make sure you close parentheses after the angle before you divide by 5. And we end up getting angle z to be 44.539 degrees. Okay, now note that we should have two possible triangles. My calculator is only ever going to give me one answer. Since we're doing the sine inverse, it's only ever going to give me an acute answer. Well, if you look back at our picture, angle z, which would be this angle right here, can either be acute or obtuse. And so keep in mind, sine will only ever give us the acute one. It's up to us to find the obtuse option. So this 44 degrees is our reference angle. To find the obtuse option, we would take 180 minus angle z. So we will end up getting angle z is 135.461 degrees. Now before you accept this answer, I'm going to add that to the other known angle to make sure that we're still under 180 degrees, which we get 161, so this answer is reasonable. Those are my two possibilities for angle z. This is how you could prove that there are two possible triangles. With the next case, I'm going to set up the law of sines the same, except now instead of 5 centimeters, we know that side x is 9. Still going to look for possible angles for angle z. We will cross multiply. We'll end up getting the sine of z is equal to 8 sine of 26 divided by 9. We'll take the sine inverse. I'm going to go ahead and save that step in the calculator for you. And we will end up getting 22.93 degrees. Again, same thing. Sine inverse only gives us acute angles. We have to then go searching for the obtuse option. This is angle z. This would be the obtuse option. We need to take 180 minus angle z to find the other possibility. So I'm going to take 180 minus the 22.93, and I end up getting 157.07 degrees. Before we accept this answer, I'm going to add it to the other known angle that's already set. And when I do that, I get 183 degrees. That's already over 180, so we're going to reject this answer. This would be the only possible angle for angle z, which verifies that there's one possible triangle. Again, you could look back to this picture, and that does verify with what we know. This angle is absolutely acute. Angle y is going to have to be the larger one, the obtuse angle. So we know one possible triangle. The last one, same idea. Sine of 26 degrees over the side that we know, 3, will equal the sine of angle z over 8. We'll get the sine of z by itself, which will be 8 sine of 26 over 3. From here, if you were to simplify this down to the approximate answer, we get the sine of z is approximately equal to 1.169. Well, this ratio is larger than 1, so you're going to get an error when you go to take the sine inverse of this ratio. That tells us that there is no angle z. That means that there's no possible triangle. Oops. From here, that would then be another way that you could verify no triangles. Right here, sine inverse is larger than 1. So we are done.